Deep brain stimulation currently is not FDA approved for Tourette syndrome. It's still at the very research level. We do know that it helps these patients, we just don't know how it helps them. So one of our goals is first to understand where the symptoms of Tourette syndrome in the brain start from, and two, how deep brain stimulation changes the brain function so that it's, improving. We have implanted 4 electrode arrays in these patients, and this was the first time that so many arrays were implanted in humans for Tourette syndrome. And we needed to make sure that we were implanting them in the right spots. So the surgery actually lasted 13 hours in both cases, so we have done this in 2 patients so far. And these patients are awake during the surgery because we really need to have them respond to our command so that we know for sure that we've implanted the electrodes in the correct places. So this is an X-ray after the first surgery with our first patient. The patient has 2 electrode leads in the deep brain structures. There's actually 2 of them. Our surgeon does an excellent job making it symmetric. These arrays will have 4 contacts. And then we also have 2 arrays that are sitting on top of her brain, and these are sitting on top of her motor cortex. So these basically can tell us when voluntary movements are happening as well as involuntary movements, whereas the deep contacts will tell us when the tics are happening. These contacts are also there for stimulation. In the brain mapping lab, our students are graduate level engineering students, and because the activity coming from the brain is electrical activity, they're basically doing signal processing algorithms, which we would do on electrical signals. So they try to learn from the brain at different states, for instance when the patients are at a baseline or when they're not ticking, and then we will ask them to let go of their tics. We will do a lot of recordings during ticking. We also do recordings during voluntary activity, because we wouldn't want to be able to detect as many tics as we can, but we don't want to confuse that with voluntary activity. So that's what the students do, so they're very involved in the signal collection. And then they go back to their computers and they analyze these signals and try to find statistical differences in how this information can help with the design of the responsive deep brain stimulator.